Welcome back, fellow computer touchers, professional computer touchers. It is approximately 2:25 a.m., but we're back once again. First time doing this problem, by the way. This is Power of 326 LeetCode Power of 3. This problem is not too bad. I'm going to show you a slower solution than is possible, right? But I think it's a good solution. Obviously, it's not the best solution, but I think it's the most intuitive solution, right, for learning to gain the intuition around these problems. And then I think the great thing about solutions like these is starting with the worst solution, right, allows you to see how on each iteration of your solution to a problem, how you can make it much better, right? So I think this is a good stepping stone to start and kind of beat the problem, right, with a really cheap way. And then from there, you can iterate on this on your own and slowly read the solutions and then try and make it better, right? First time doing this problem, by the way, confirmed. So power of 3. Given an integer n, return true if it is a power of 3. Otherwise, return false. So a simple problem at hand, right? An integer n is a power of 3 if there exists an integer x such that n is equal to 3 to the x. So what are some basic powers of 3, right? Well, we have that 3 to the 3, right, is equal to 27. Let's just even go even before that. 3 to the power of 2 is equal to 9, right? And 3 to the power of 4 is equal to 81, right? So even from just looking at things like this, right, you can already kind of get an intuitive way of doing this, right? So if you're ever given this problem in an interview, you can just you might be able to give the best answer, but you can say, well, how would we do this, right? Well, we know that we can get the value of a number, right? A power of a number by giving the number and exponentiating it, right, with the power that you want. So if that's the case, we can just automate this process, right? And so what we'll just do is we'll just write the scaffolding. We'll say, hey, while our current value, right, does not equal n, right, which means that the value that we're calculating this for, right, hasn't reached n, we're going to calculate the cur for this power, right? If the value that we calculated this for, right, if cur is greater than n, so let's just say they ask us if 45, let's just say they ask us that 45 a power of 3, right? So we'll start at 0. 3 to the 0 is 1, 3 to the 1 is 3, 3 to the 2 is 9, 3 to the 3 is 27, 3 to the 4 is 81. So if cur is ever greater than the number that we're looking for, which is n, right, then we're going to say return false, right? It's not a power of 3, right? And so what's important, right, is that you can see that if we ever make it out here, then cur equals n, right? Because we said this loop is going to run while cur does not equal n. Right? So while the base that we calculated, while the power that we calculated for 3 is not equal to the number they want to check if it's a power of 3 of, right, then we're just going to jump out, right? And we're going to say then cur must equal n, right, because we made it out. So then we can return true, right? It is a power of 3. So now we can just write this, right? And then what's cool about this is you can take it to any problem. And a lot of the better solutions of this you can also take to any problem. But I think a slower solution like this is more intuitive to get the grasp on what's actually happening if your math isn't the best. So the first thing we're going to have to do is comment out all these weird things that I wrote, right? And the first thing we have to check, right, is if n is equal to 0, right, then we're going to return false, right? Because if the number they want us to check for is 0, right, then we're just going to return false. And so we need some other values, right, to kind of hold us in place. Power is going to start at 0, right, because we want to start at 0. While cur does not equal n, right, so while cur is not equal to the golden number, we're going to calculate cur for this power, right? And so what you can do is you can say 3 to the power, right? And if cur is greater than n, right, we're just going to return false. It's not a power of 3. Right, if we make it out of here, though, then cur does equal n, right? And it is a power of 3, so we can return true. And so, boom. The final thing we have to do is just increment power, right? Because we have to make sure that we're, linearly iterating through all the possible powers of 3. And if we click submit, we can see that this works. It's not the fastest solution ever by any means. So the time complexity here is going to be linear time, right? Linear being if we're given a number, let's just say like 3 trillion, and we have to check if it's a power of 3. We're going to start at 0 and linearly check every possible power of 3 until we get to that number or we pass it, right? Fortunately enough, right, it's pretty easy to reach this. So it's not the worst thing in the world, right? Because if you think of 3 to the 19, right, that's like, I think 3 to the 19 passes the boundary for a certain data type, right? Depending on the size you use to store the data type. So it's not an algorithm that's gonna take forever or anything like that. It's just not as fast as the faster algorithms, but it's still, in the sense of math, it's not the slowest thing in the world. So the space complexity is also constant space complexity. We're just using a couple different variables here to manage how we're going to be iterating while we calculate this value. And so this is power of 3, simple, slow solution, but intuitive. Farewell.